Let us study the vertical asymptotes of rational functions. We're going to introduce the concept of asymptotes. We will explain vertical asymptotes, and then we'll go ahead and look at how we can calculate vertical asymptotes. An asymptote is a line that the curve approaches as it tends towards infinity in either direction. If we look at this first graph here, you can see that at this point, x equal to this point where x is -1, if we drew a vertical line, you'll see that this graph right here tends towards the vertical line here, and you can also see the x-axis as well as an asymptote because it doesn't really touch the line, but it gets really close. And then we can see that here as well, that we have a vertical asymptote, which is the straight line that is vertical. So we have a vertical line here, x equal to -1 is a vertical asymptote, and then y equal to 1 is a horizontal asymptote. But in this lesson, we will focus more on vertical asymptotes. So vertical asymptotes are lines that correspond to the zeros of the denominator of a rational function. So that means that when we have a rational function, which has generally a rational function has a function in the numerator and a function in the denominator, and we want to solve the denominator to get the asymptote. Let's look at some examples here. So what is the vertical asymptote of y equal to 3/2x? To get the vertical asymptote, we're just solving the denominator. So 2x equal to 0, we divide by 2 on both sides. So x equal to 0. This is the vertical asymptote. That's what we're trying to do. Another example. What is the vertical asymptote of x plus 2 divided over x plus 3? So what we're saying here is to find the vertical asymptote, what we just simply do is x minus 3 equal to 0. We add 3 to both sides. So x equal to 3, that is our vertical asymptote. What is the vertical asymptote of 3x over x squared minus 5x minus 14? So what we're going to do here is we're going to try to solve x squared minus 5x minus 14 equal to 0. Now you have a few choices. You can use the quadratic formula, or you can use just plain factorization or factoring. Let's try both just so that you can see which one works better for you. So I'm going to just factor this. So we have, what are the factors of -14 that add up to -5? So we have 7 and 2 give us 14. So we're going to put the negative on the 7 and the positive on the 2. So we now have x minus 7, x plus 2 equal to 0. So for these two products to give you 0, one of them or each of them could be 0. So we have x minus 7 equal to 0. And then we also have x plus 2 equal to 0. So we add 7 to both sides. So x equal to 7. We subtract 2 from both sides. X equal to -2. So x equal to 7, x equal to -2. Those become our vertical asymptotes. Okay, let's try the quadratic formula to see if we get the same result. The quadratic formula is x equal to minus b plus or minus square root of b squared minus 4ac divided by 2a. So here a is equal to 1, b is equal to -5, and c equal to -14. So x is going to be equal to negative of -5 plus or minus square root of -5 squared minus 4 times 1 times negative 14 divided by 2 times 1. So this is going to, minus minus here is going to give us 5 plus or minus square root of negative 5 squared is going to be 25 minus 4 times 1 minus 4 times minus 14 plus 56 divided by 2, which is 5 plus or minus square root of 81 divided by 2, which is going to give us 5 plus or minus square root of 81 is 9 divided by 2. So we have two choices, 5 plus 9 over 2 or 5 minus 9 over 2. This is going to give us 14 over 2 or negative 4 over 2. So now we have 7 and then we have minus 2. So you can see that regardless of which approach you use, you should get the same result. Finally, what is the vertical asymptote of y equal to 5 over x squared plus 14? Now this is going to be interesting because we have x squared plus 14 equal to 0. We subtract 14 from both sides, so x squared equal to negative 14. Now with vertical asymptotes, remember we're looking at the coordinate axis. You must have the solution to your denominator or the zero of your denominator must result in a real number. Here we're not going to have a real number because x is going to be equal to plus or minus square root of negative 14, which is going to give us a complex number, which will be plus or minus square root of 14i. Because of this situation where you cannot get a real number, this function does not have a vertical asymptote.